All right. So if we look here, I should check super quick what time we get out. I think our classes today, except for 4th hour, are all, they're all 45 minutes. So we get out of here at 55. Okay. Okay. So, again, what we're going to be doing today is solving radical equations. And as I was saying, with a radical equation, it's just an equation that has a square root, a cubed root. We'll have 4th roots and we'll have 5th roots, okay? And these are kind of the rules that you go through when you do this. So the first thing you have to do is get that square root or cubed root or 4th root by itself. And then what you do to get rid of a radical, if it's a square root, to get rid of a square root, you square both sides. To get rid of a cubed root, you cube both sides. To get rid of a 4th root, you put both sides to the 4th power and so on. And then in these problems, there's times that you'll get an answer and it won't work. So what they have you do then is check your solution back in the original equation, and then you can tell if you got it right. With you guys being the regular Algebra 2 class, I didn't put any in that are no solution. All of them work. So it's good to check your solution because then you know if you did it right. But you don't have to check it to see if there's a no solution just because I didn't put any in like that. So again, we'll go and try to get started here. So we have that square root. So we want to keep that square root by itself on one side. So I have to get rid of this -1. So I add 1 to both sides. This goes away. And then I have the square root of x minus 2 equals 5 plus 1, which is 6. Okay. Then what I'm going to do is to get rid of a square root, you square both sides. So we square this as well as this. When you square a radical, they cancel each other out. And what we're going to get is x minus 2. And then over here, we have 6 squared, which is 36. Okay. Then what we're going to do is add 2 to both sides. And we get x equals 38. And that is our answer. And then, like I said, what's a good idea is to go ahead and put that back into the original problem. So if you put 38 in here minus 2, and then it's subtract 1 and see if it's equal to 5. 38 minus 2 is 36. And you have to take the square root of that and then subtract 1 and see if it's equal to 5. Well, the square root of 36 is 6. And 6 minus 1 is 5. So that does check. So as far as like, if I was putting problems on here that were no solution, you have to check it. If you don't check them and you did the math right, you'd be fine. But it's a good idea to do that, even if you just did it mentally, to see if you did it correctly. So this one here already has the square roots isolated on both sides. And so what you can do here to get rid of that is just take both sides to the second power. And when you do that, what happens is a square root squared cancels, and you would just have 2d minus 5. And then here, the square root square root squared cancels, and you would have d minus 1. And then you just go ahead and solve that. So we would subtract d. 2d minus d is d. Minus 5 equals -1. And then I would add 5. And I would get d equals -1 plus 5 is 4. So that is my answer. Okay. Now again, like I said, if you go to check that, on one of them, you would have 2 times 4 minus 5. And in the other one, you'd have 4 minus 1. So 2 times 4 is 8, minus 5 is the square root of 3. And over here, 4 minus 1 would be the square root of 3. So that does 10. Okay. So on your assignment, I'm not going to require you to check them, but it's a good idea, especially if you were on a test. I would certainly do that. So now if we go here, this is just the same thing. So we're going to subtract 2. And then we get square root of 3p plus 7 equals 6 minus 2 is 4. So now we have that square root by itself. So what we would do is square both sides. The square root squared cancels. So we have 3p plus 7. 4 squared is 16. And then we go ahead and solve that. So I'd subtract 7. And I have 3p equals 9. Divide by 3. And p is 3. And then if you wanted to check that, you would have 3 times 3 plus 7 under the square root. And then you check if you added 2, would you get 6? Well, this is 9 plus 7, which is 16. And you check if I took the square root of 16 plus 2, do I get 6? Square root of 16 is 4 plus 2 is 6. So this does work out. We did one like this. Are you guys okay with these two? Everybody understand these things? Okay. So let's go to our next page here. And what is going to be different with this one is we're going to have cubed roots. Now with cubed roots, it's the only difference is you're going to take both sides to the third power. So here, what I would do is I would take this to the third power as well as this to the third power. The cubed root cubed cancels, and you would have 2w. 4 to the third power. So if you guys are unsure, because sometimes you're going to have some cubes that you're not sure about, if you use a calculator, most calculators will have this caret looking thing. And so was it 4 to the third? So if you just go 4 up arrow 3, that is 64. Okay. You also could just go 4 times 4 times 4. That would be 4 cubed also. So this is 64. We divide by 2. And W is 64 divided by 2 is 32. Now if we check that one, we have the cubed root of 2 times 32. And we're checking if it's 4. So this would be the cubed root of 64. And to show you how to do that on a graphing calculator, graphing calculators have this math key right here. And if you hit that, number 4 is a cubed root. So if you either use your down arrow to go to number 4, or if you just punch number 4 and hit enter, what will happen is it'll say the cubed root and you just enter what you're taking the cubed root of. So if we do the cubed root of 64, that is 4. Okay, so back here, this is 4. So this does check. Now in this one, what we would do is just bring our 6 over, and that 6 is kind of understood to be positive, so I'd have to subtract 6. These are gone, and then I have the cubed root of q minus 4 equals 9 minus 6, which is 3. Okay, now what I would do to get rid of that cubed root is I cube both sides. Okay, cubed root cubed cancels, so this is q minus 4. 3 to the third power is 27. So then I add 4. And Q would equal 27 plus 4 is 31. Now again, how 3 cubed is 3 times 3 times 3, which is 27. But you also could have done 3 up arrow 3, which is 27. And then to check that one, what we would do is go 6 plus the cubed root of 31 minus 4 and check if that equals 9. So 31 minus 4 is 27. And so we check is 6 plus, now the cubed root, again, you hit that math key, and then it's the fourth one, which you can just hit 4, and it was 27, and that is 3. So if we go back, this was 3, and 6 plus 3 does equal. Do you think you're good on that? Or do you need to see another one, or do you understand? Okay. So I have a worksheet made up, and again, it says on this worksheet to check for extraneous solutions, that's what it's called, if a solution doesn't work. And you should not have any that don't work. If you want to check, you can, but I'm not going to require you. Okay? And we'll finish this section tomorrow, and then you will we'll have a practice quiz Monday and a quiz on Tuesday.